Okay, so in last lecture we have revised the some part of the heat exchanger topic. That is, we have revised about the what is meant by heat exchanger, what are the applications of the heat exchanger, then classification of heat exchanger. After that, we have discussed about the analysis of the heat exchanger. In that, we have covered the LMTD method for the parallel fluid exchanger, then LMTD, that is log mean temperature difference for the counter fluid exchanger, and after that we have discussed about the overall heat transfer coefficient. Okay, so we have derive the equation for the overall heat transfer coefficient. So what is the overall heat transfer coefficient? So for that we have used that equation Q is equal to delta T upon summation of R is equal to UA delta T is equal to UI AI delta T is equal to UO AO delta T. So from that equation we have written the equations for the different overall heat transfer coefficients. So overall heat transfer coefficient for inner surface and overall heat transfer coefficient for the outer surface. So we have derived the equation for the inner surface, that is UI is equal to 1 upon next lesson. Yes sir, UI is equal to 1 upon HI plus RI by K ln of RO by RI plus RI upon RO into 1 upon HO. So this is the UI for the overall transfer coefficient for the inner surface, and similarly we have calculated the value of overall transfer coefficient for the outer surface, that is UO. So for that we have used the equation as a UO is equal to 1 upon AO into summation of R, and by simplification of that we get the equation for the overall transfer coefficient for the outer surface, that is 1 upon 1 by HI into RO by RI plus RO by K ln of RO by RI plus 1 by HO. So by using that equation, we have to calculate the overall transfer coefficient. Okay. After that, we have discussed about the falling or scaling factor of the heat exchanger. So in a heat exchanger during normal operation, the tube surface gets covered by a deposit of ash, soot, dirt, scale, etc. This phenomenon of rust formation and deposition of fluid impurities is called as falling, and due to this falling what will happen, the thermal resistance is increases and eventually the performance of the heat exchanger is lowers. Okay, so each HSI and HSO will be the heat transfer coefficient for the scale deposited on the inside and outside surface respectively. Then what is the value of thermal resistance? RSI is equal to 1 upon AI into HSI, and RSO is equal to 1 upon AO into HSO. And what is meant by falling factor? Falling factor is nothing but it is the reciprocal of the scale heat transfer coefficient, means RF is equal to 1 upon HS. Okay, and how to determine this falling factor by the experimentally, that is RF is equal to 1 by U dirty minus 1 by U clean. Okay, so by using that equation we have to calculate the value of falling factor by the experimentally. Okay, so from this diagram we have to understood the from the hot fluid to cold fluid there are total 5 resistances are there, and summation of R total is equal to thermal resistance due to the convection, then inside surface scale is there, then conduction is there, then outside surface scale is there, and then convection is there. So from that we get the summation of R, that is overall resistance for that particular diagram or for that particular heat exchanger when the scale formation is takes place. And from that we get the equation for the overall heat transfer coefficient for the inner surface and overall heat transfer coefficient for the outer surface. Okay, so we get the equation of ui is equal to 1 upon hi plus rfi plus ri upon k ln of ro upon ri plus ri by ro into rfo plus ri by ro into 1 upon ho. So by using that we have to calculate the overall transfer coefficient for the inner surface when there is this scale, and similarly we have to calculate the overall transfer coefficient for the outer surface. UO is equal to 1 upon RO by RI into 1 upon HI plus RO by RI into RFI plus RO by K ln of RO by RI plus RFO into sorry RFO plus 1 upon HO. Okay, so when falling factor is neglected then we have to remove that terms related to the falling, and when the we have to considering the tube is thin walled, then we have to remove the terms which is related to the conduction. Okay, after that we have discussed about the some problems related to the LMTD method. So in that we have calculated the q. In the first problem we have to calculate the value of q. From that q value we have calculated the value of tc2. Then we have calculated the value of theta m. So as we know that LMTD is nothing but theta 1 minus theta 2 divided by ln of theta 1 upon theta 2. And from that we have designed the heat exchanger. So for that we have to calculate the area. As we know that what is the standard equation, q is equal to u into a into theta m. So from that we have calculated the value of area. Okay, similarly in second problem we have calculated the value of area But in that problem, first of all we have calculated the value of q, then we have calculated the value of m dot c, and by using the lmtd method we have calculated the value of area. Okay, and in the third problem, first we have calculated the value of overall heat transfer coefficient for the outer surface, then we have calculated the value of AO, then theta m, and then q. Okay, so these are the problems which is related to the lmtd method. After that we have discussed about the another method for the designing of the heat exchanger, that is heat exchanger effectiveness and number of transfer units. Okay, if inlet and outlet conditions are known to us, then we have to use the lmtd method. But if inlet and outlet conditions are unknown to us, at that time we have to use this method, that is effectiveness and number of transfer unit method. So what is meant by heat exchanger effectiveness? So as we know that it is defined as the, it is the ratio of the actual heat transfer to the maximum possible heat transfer. So epsilon is equal to q upon q max. So how to calculate the value of q? As we know that what are the equations for the q, that is m dot h into cph into bracket th1 minus th2, and for the cold fluid m dot c into cpc into bracket tc2 minus tc1. So as we know that mass flow rate into specific heat is nothing but heat capacity, so m dot h into cph is nothing but CH, and m dot C into CPC is nothing but CC. And we have to calculate the value of CH and CC, and from that we have to understood which value is minimum and which value is maximum. So minimum value is nothing but C minimum and maximum value is nothing but C max. Okay, so by comparing that CH and CC, we have to understood C minimum and C maximum. So for the calculation of the Q max, so whatever the four temperatures are there, in that four temperatures which difference is maximum, that is TH1 minus TC1. So for the, to get the maximum temperature difference, there is a need of minimum heat capacity, that is delta T is nothing but q upon c. And if you want the maximum temperature difference, at that time c should be minimum, so therefore q max is nothing but c minimum into th1 minus tc1. So by using that we get the maximum heat transfer, and from that we get the equation for the effectiveness, that is ch into bracket th1 minus th2 divided by c minimum into th1 minus tc1. And if cold fluid is there, then cc into bracket tc2 minus tc1 divided by c minimum into bracket th1 minus tc1. And from that we have to calculate the value of q. Q is equal to epsilon into c minimum into bracket th1 minus tc1. So this is about the rate of heat transfer and effectiveness equation. Then what is meant by heat capacity ratio? Heat capacity ratio is denoted by R, and it is the ratio of the minimum heat capacity to the maximum heat capacity. Then number of transfer units, how to calculate the number of transfer units? NTU is nothing but, it is the measure of the effectiveness of the heat exchanger. And what is the equation for the NTU? That is U into A divided by C minimum. By using that equation, we have to calculate the value of NTU. After that, we have derived the equation for the effectiveness for the parallel flow heat exchanger. So for that, we have considering one small element, and we have written the equation for the dq for that particular small element, U into d into th minus tc. Then we have written the equation for the hot fluid and cold fluid for that particular small elemental area. So for the hot fluid, temperature is reduces, so therefore we have taken the negative sign. So dq is equal to minus m dot h cph into dth, and for the cold fluid m dot c into cpc into dtc. So m dot h into cph is nothing but ch, and m dot c into cpc is nothing but cc. So from that equation we have calculated the value of dth and dtc, then we have taking the difference of that two. So we get the equation for the dth minus tc is equal to minus u into dth minus tc into bracket 1 upon ch plus 1 upon cc. So th upon tc, that part we have taken at the left hand side, we get the equation as a dth minus tc divided by th minus tc is equal to minus u into da into bracket 1 upon ch plus 1 upon cc. So we have taken the integration from 1 to 2, and for the area 0 to a, and after the integration we get the equation as a th2 minus tc2 divided by th1 minus thc1 is equal to e raised to minus u into a divided by ch into bracket 1 upon 1 plus ch upon cc, and that is the equation number 3. And as we know that the expression for the effectiveness epsilon is equal to ch into bracket th1 minus th2 divided by c minimum th1 minus tc1 is equal to cc into bracket tc2 minus tc1 divided by c minimum into bracket th1 minus tc1. So by this simplification, first we have calculated the value of th2 and tc2, and by putting this value into equation number 3, we get the equation number 6, that is effectiveness epsilon is equal to 1 minus e raised to minus UACH divided by CH into bracket 1 upon CH upon CC divided by C minimum into bracket 1 upon CH plus 1 upon CC. That is the equation number 6. And if Cc is greater than Ch means C minimum is nothing but Ch and C max is nothing but Cc. So by replacing the Ch and Cc value as a C minimum and C max, we get the equation number 7, that is epsilon is equal to 1 minus e raised to minus u into a divided by C minimum into bracket 1 plus C minimum upon C max divided by 1 plus C minimum upon C max. So this is the equation number 7. And if another condition is there, if Cc is less than Ch, at that time C minimum is nothing but Cc and C maximum is nothing but Ch. So by putting that value, we get the equation. By rearranging the term, we get the common equation as a epsilon is equal to 1 minus e raised to minus ua divided by C minimum into bracket 1 plus C minimum upon C max divided by 1 plus C minimum upon C max. And as we know that NTU is nothing but UA divided by C minimum and R is nothing but C minimum upon C max. So by replacing that value, we get the equation for the effectiveness, that is 1 minus e raised to minus NTU into bracket 1 plus R divided by 1 plus R. So this is the effectiveness for the parallel flow heat exchanger. Similarly, we have derived the equation for the effectiveness for the counter flow heat exchanger. So we have represented the graphical representation for that counter flow heat exchanger, and for that same manner as the parallel flow heat exchanger, we have derived the equation, that is dq equation number 1, then equation number 2, then we have calculated the value of dth, then dtc, then we have taken the difference, and we get the equation number 3 as a th2 minus tc1 divided by th1 minus tc2 is equal to e raised to u into a divided by cc into bracket 1 minus cc upon ch. Then we know that equation for the effectiveness. In that equation, we have calculated the value of th2 and tc2, and that value we have put it into equation number 3. And after this simplification, we get the equation as a 1 minus epsilon c minimum upon ch divided by 1 minus epsilon c minimum upon cc is equal to e raised to ua divided by cc into bracket 1 minus cc upon ch. So I have considered the first condition, cc is less than ch, then c minimum is nothing but cc and c maximum is nothing but ch. So after simplification, we get the equation for the epsilon. Epsilon is equal to 1 minus e raised to ua upon c minimum into bracket 1 minus c minimum upon c max divided by C minimum upon C max minus e raised to UA C minimum 1 minus C minimum upon C max. Okay. So after simplification, we have considered the x as a term. So we get the in the form of x, that is epsilon is equal to e raised to x minus 1 divided by e raised to x minus C minimum upon C max. Then divided by e raised to x, then we get the equation. So final equation we get as a epsilon is equal to 1 minus e raised to minus n2 into bracket 1 minus r divided by 1 minus r e raised to minus n2 1 minus r. So these are the equation for the parallel flow and counter flow heat exchanger. Then we're considering the two cases for condenser and evaporator. The value of Cmax is infinity. So from that we get the value of R is equal to 0. So from that we get the equations for the effectiveness for parallel flow, that is 1 minus e raised to minus n2, and for the counter flow 1 minus e raised to minus n2. So same equations for the condenser and evaporator if parallel flow and counter flow is there. Then case number 2 I have considered, that is when R is equal to 1, then we get the effectiveness for the parallel flow heat exchanger as a 1 minus e raised to minus 2 n2 divided by 2. And for the counter flow, we have used the L hospital rule, and by using the L hospital rule, we get the effectiveness as a NTU divided by 1 plus NTU. Okay. After that, we have solved some problems related to the effectiveness and NTU method. In that, we have calculated the M dot C. Then we have calculated the value of effectiveness. Then we have calculated the value of ENTU, and from that ENTU we have calculated the value of area. Okay. So this is the first problem. Then in the second problem, we have calculated the value of CH, CC, R, then ENTU, then effectiveness. Then we have calculated the value of outlet, that is TS2 and TC2 for the parallel flow arrangement and for the counter flow arrangement. Okay. Then we have discussed about the third problem. In that we have calculated the value of Q, then TS2, and by using that we have calculated the value of ENTU, that is 1.09. Okay. And then we have discussed one point, that is heat pipe. This is actually in the unit number 5, but this is related to the heat exchanger. So I have taken in continuation with the topic number 6, that is heat pipe. So heat pipe is nothing but it is a device which transfer the heat from one location to the another location. And in the heat pipe there are three sections are there: evaporator section, adiabatic section, and condenser section is there. Okay. So in the evaporator section, what will happen, heat is coming inside the particular tube, whatever the water which is present inside the tube, because of that what will happen, the water is converted into the vapor will be coming at the right hand side. and that vapors will be converted into the liquid, and that heat is transferred to the heat sink. Okay, again that vapors will come into the evaporator section, again that water is converted into the vapor. So in this way the heat transfer takes place from the one location to the another location. This is the heat pipe construction working and principle. Then what are the applications? That is compact electronics enclosures, aerospace, medical, HVAC. And what are the advantages of the heat pipe? That is long life, minimum maintenance, compact size, zero contamination, and zero back pressure. Actually, this heat pipe is in the unit number 5. Now we have to start the unit number 5. In that, heat pipe point is there, but already we have covered that point. So in unit number 5 we have not again covering this heat pipe. Okay, so now unit number 5, unit number 6 is over. In unit number 5 we have completed one point, that is heat pipe. So all of you write down the unit number 5, next heading unit number 5, and give the title of the topic as a boiling and condensation. All of you write down next heading unit number 5, unit number 5. Okay, so unit number 5, the last topic, last point, introduction to heat pipe, construction, working, advantage and application. So that point we have covered in the unit number 6. So again I will not cover that point in this topic. Okay, so we have to remember this heat pipe is in the unit number 5. वाटलं तर तुम्ही आता युनिट नंबर जिथे हीट पाईप लिहिले तिथे युनिट नंबर 5 लिहा, म्हणजे तुम्हाला समजून जाईल की हा हीट पाईप जो आहे तो पॉईंट युनिट नंबर 5 मधला आहे. ओके, सो ऑल ऑफ यू राईट डाऊन द न्यू हेडिंग युनिट नंबर 5, बॉइलिंग अँड कंडेन्सेशन. इथं आपले टोटल 4 टॉपिक संपलेले आहेत बघा. पहिला सेक्शन ऑलरेडी कंप्लीट केलेला आहे, त्याच्यानंतर 6वा टॉपिक झालेला आहे, 5व्या टॉपिक मधला पण हीट पाईप झालेला आहे. 2-3 लेक्चर मध्ये पण आपला हा युनिट नंबर 5 पण कंप्लीट होत आहे. ओके, देन वी हॅव टू कव्हर दी युनिट नंबर 4, दॅट इज कन्व्हेक्शन. ओके, सो ऑल ऑफ यू गिव्ह न्यू हेडिंग युनिट नंबर 5, बॉइलिंग अँड कंडेन्सेशन, boiling and condensation, boiling and condensation. Write down the syllabus for this. Syllabus, boiling and condensation. Then write down the syllabus. Syllabus. Write down the syllabus for the boiling and condensation. Write down boiling heat transfer. Boiling heat transfer. Boiling heat transfer. Boiling heat transfer, comma, types of boiling, comma, types of boiling, types of boiling, comma, pool boiling curve, pool boiling curves, pool boiling curves, pool boiling curves, comma, force boiling phenomenon, force boiling phenomenon, force boiling phenomenon, force boiling phenomenon, comma, condensation heat transfer, condensation heat transfer, condensation heat transfer, condensation heat transfer, comma, film wise and drop wise condensation, film wise and drop wise condensation, film wise and drop wise condensation, film wise and drop wise condensation. Then next, introduction of heat pipe. Already हा पॉइंट आपण कव्हर केलेला आहे. Introduction of heat pipe, introduction of heat pipe, introduction of heat pipe, in bracket construction working, in bracket construction working, advantages and applications, introduction of heat pipe, in bracket construction comma working, comma working, comma advantages advantages and applications and applications. Okay, once again, this is unit number 5. What is the title of the unit? That is boiling and condensation. Boiling and condensation. What is the syllabus of this? That is, first point is a boiling heat transfer. Boiling heat transfer. Then second point, types of boiling. Types of boiling. Then pool boiling curves. Then force boiling phenomenon. Then condensation heat transfer. In that, film wise condensation and drop wise condensation is there. Okay. Then introduction to heat pipe, that is construction, working, advantages and applications. Okay. Yes, sir. Open the syllabus of unit number section 1. Section 1 syllabus. Okay. Zoom it. Okay. Hmm. Okay. So already आपण section 1 complete केलेला आहे. Unit number 1 conduction. In that we have completed modes of heat transfer, steady state heat conduction, unsteady state heat conduction. Okay. So this is the unit number 1. Then we have completed the unit number 2. What is unit number 2? That is unit number 2 is not there. Okay, leave it. Unit number 2 is nothing but extended surfaces were completed. After that, you have completed the unit number 3, that is radiation. This is about the unit section 1. In this section 2, we have completed the unit number 6, that is heat exchanger. And now we have started the unit number 5, that is boiling and condensation. Only one topic is remaining, that is unit number 4, that is convection. So after completion of the unit number 4, boiling and condensation, it requires two or three lectures for the boiling and condensation. After that, we have to start the unit number 6, that is unit number 4, that is convection. So this is little bit vast topic, that is convection. In that, forced convection is there and natural convection is there. Okay. So now we have to start the unit number 5. Okay. So actually in the earlier syllabus, this is the unit number 5, but we have to write, unit number 4 is there, but now it is unit number 5. So by mistakenly I have written there unit number 4. So all of you write down unit number 5 and boiling and condensation. Okay. Boiling and condensation. Okay. So write down first point, vaporization. We have to cover the basic points related to the boiling and condensation. So all of you write down the first point as a vaporization. So can anyone tell me what is mean by vaporization? Unmute yourself and tell me what is mean by vaporization. Anyone? Vaporization म्हणजे काय असणार आहे? So vaporization is nothing but it is the process by which liquid changes to gas or vapor. समजले का बघा? व्हॉट इज मीन बाय वेपरायझेशन? वेपरायझेशन मध्ये काय होणार आहे, तर जे काही लिक्विड आहे त्या लिक्विडचं कन्व्हर्जन गॅसमध्ये होईल किंवा वेपर्स मध्ये होणार आहे. दॅट प्रोसेस इज नथिंग बट वेपरायझेशन. All of you understood what is meant by vaporization? Liquid is converted into gas or vapor, that is nothing but vaporization. Okay, so all of you write down the definition of the vaporization. Write down the first point, vaporization. Vaporization. Write down vaporization. Vaporization. Write down, it is the process, it is the process by which, it is the process by which liquid changes to, it is the process It is the process by which liquid changes to gas or vapor, by which liquid changes to gas or vapor, liquid changes to gas or vapor, that is nothing but vaporization. Okay, so this is about the vaporization. Then can anyone tell me what is meant by evaporation and what is meant by boiling? Anyone? तुम्ही सांगा मला. Evaporation and boiling is the same process or different process? Anyone unmute yourself and tell me about that. What is meant by evaporation and what is meant by boiling? Evaporation मध्ये काय असणार आहे आणि boiling मध्ये काय असणार आहे? Can anyone tell me what is meant by evaporation and what is meant by boiling? Evaporation and boiling same असणार आहे की वेगळं असणार आहे? Anyone unmute yourself and tell me about that. Whether evaporation and boiling is same or different? Anyone? कोण सांगताय? Whether evaporation and boiling is same or different? Anyone tell me about that? Whether evaporation and boiling is same or different? Vinayak?
Different.
Different. So what is difference? धनश्री, काय डिफरन्स असणार आहे इव्हॅपोरेशन आणि बॉइलिंग मध्ये?
Evaporation is takes place at low temperature also, and it will take at surface.
Okay, and what about the
And,
boiling?
and boiling is takes place at high temperature only, and it will occur at any surface of the liquid.
Okay, correct आहे. So what is meant by evaporation? Evaporation is nothing but vaporization only at surface of liquid. म्हणजे जे लिक्विडचं कन्व्हर्जन वेपर मध्ये होणार आहे, ती प्रोसेस जी असणार आहे ती कुठं असणार आहे? लिक्विडच्या सरफेस वरती असणार आहे. दॅट इज नथिंग बट इव्हापोरेशन. आणि म्हणजे इव्हापोरेशनला okay, so evaporation will act at vaporization only at surface of the liquid. म्हणजे लो टेम्परेचर असेल त्यावेळेला सरफेसचं काय होणार आहे? लिक्विडचं कन्व्हर्जन वेपर मध्ये होणार आहे. ओके, सो evaporation will be act at the low temperature. And what about the boiling? Boiling is nothing but vaporization that occurs throughout the liquid. जी काही व्हेपरायझेशनची प्रोसेस असणार आहे, म्हणजे जे काही लिक्विडचं कन्व्हर्जन व्हेपर मध्ये होणार आहे, ते कुठं होणार आहे? तर जे काही लिक्विड आहे त्या लिक्विड मध्ये थ्रू आउट ही प्रोसेस असणार आहे, कन्व्हर्जन ऑफ लिक्विड टू व्हेपर. ओके, व्हेपरायझेशन दॅट ऑकर्स थ्रू आउट दी लिक्विड. जी काही व्हेपरायझेशनची प्रोसेस आहे ती त्या पूर्ण लिक्विड मध्ये होणार आहे. म्हणजे जे काही लिक्विड आहे त्याचं कन्व्हर्जन व्हेपर मध्ये जे होणार आहे ते थ्रू आउट लिक्विड होणार आहे. पण इव्हॅपोरेशन मध्ये काय असणार आहे? फक्त सरफेसलाच काय होणार आहे? लिक्विडचं कन्व्हर्जन वेपर्स मध्ये होणार आहे. ओके, सो दिस इज द डिफरन्स बिटवीन द इव्हॅपोरेशन अँड बॉइलिंग. ओके, इव्हॅपोरेशन इज नथिंग बट vaporization only at surface of liquid. And what about the boiling? Boiling is nothing but vaporization that occurs throughout the liquid. म्हणजे इथं टेम्परेचर जास्त असणार आहे as compared to the evaporation process, as compared to the evaporation process. Okay, so all of you write down the second definition. Evaporation, write down the evaporation, write down. evaporation is evaporation is evaporation is vaporization. Evaporation is vaporization only at surface of liquid. Evaporation is vaporization only at surface of liquid. Only at surface of liquid. Okay, so this is about the evaporation. Then write down the what is meant by boiling. Write down boiling. So Write down vaporization. Boiling is nothing but vaporization that occurs. Boiling is nothing but vaporization that occurs throughout the liquid. Vaporization that occurs throughout the liquid. समजले का बघा, जे काही लिक्विड आहे त्याचं व्हेपर्स मध्ये कन्व्हर्जन हे थ्रू आउट लिक्विड मध्ये होणार आहे. म्हणजे इथं टेम्परेचर जास्त असणार आहे, आणि बिकॉज ऑफ दॅट हाय टेम्परेचर बॉइलिंग विल बी टेक्स प्लेस. ओके, सो वेपरायझेशन दॅट ऑकर्स थ्रू आउट दी लिक्विड. ओके, तर बॉइलिंग जे असणार आहे, सो विच मोड ऑफ हीट ट्रान्सफर इज देअर बॉइलिंग मध्ये. तर बॉइलिंग मध्ये काय असणार आहे, कन्व्हेक्शन मोड ऑफ हीट ट्रान्सफर असणार आहे. ओके, हीट ट्रान्सफर इज टेक्स प्लेस ड्यू टू दी मोशन ऑफ द लिक्विड. ओके, जे काही लिक्विडचं कन्व्हर्जन वेपर मध्ये होणार आहे, म्हणजे हे वेपर जे असणार आहे ते मोशन मध्ये असणार आहे. अँड बिकॉज ऑफ दिस मोशन हीट ट्रान्सफर इज टेक्स प्लेस, सो बॉइलिंग इज नथिंग बट कन्व्हेक्शन मोड ऑफ हीट ट्रान्सफर इज दॅट. ओके, म्हणजे बॉइलिंग मध्ये जी काही हीट ट्रान्सफर होणार आहे ती कुठल्या मोडमुळे होणार आहे, बिकॉज ऑफ दी कन्व्हेक्शन मोड ऑफ हीट ट्रान्सफर. ओके, सो ऑल ऑफ यू राइट डाउन नेक्स्ट लाइन. बॉइलिंग इज दी boiling is the boiling is the convective heat transfer process. Boiling is the convective heat transfer process. Convective heat transfer process that that involves involves a phase change from that involves a phase change from that involves a phase change from liquid to vapor state. That involves a phase change from liquid to vapor state. Okay, boiling is nothing but convective heat transfer process that involves a phase change from liquid to vapor. Okay, liquidचं conversion कशामध्ये होणार आहे बॉइलिंग मध्ये, liquid to vapor. And which mode of heat transfer is there, convection mode of heat transfer is there, because heat transfer takes place due to the motion of the molecules. Okay, then boiling is possible. This is possible only when the temperature of the surface exceeds the saturation temperature. जे काही सॅच्युरेशन टेम्परेचर असणार आहे त्या लिक्विडचं, ओके, सॅच्युरेशन टेम्परेचर पेक्षा सरफेसचं टेम्परेचर काय होणार आहे, जास्त होणार आहे, एक्सीड होणार आहे. ऍट दॅट टाइम बॉइलिंग इज पॉसिबल. ओके, सो ऑल ऑफ यू राइट डाउन. दिस इज पॉसिबल ओनली this is possible only this is possible only this is possible only when the temperature of the surface this is possible only when the temperature of the surface that is Ts. temperature of surface ला आपण काय म्हणणार आहे, Ts exceeds the saturation temperature exceeds the saturation temperature, that is Tsat. saturation temperature is nothing but Tsat. समजले बघा, सरफेसचं टेम्परेचर हे सॅच्युरेशन टेम्परेचर पेक्षा जास्त असेल त्या केसमध्ये काय होणार आहे, बॉइलिंग पॉसिबल आहे. ओके, exceeds the saturation temperature, that is Tsat corresponding to liquid pressure corresponding to liquid pressure corresponding to liquid pressure. Okay, so boiling is possible only when the temperature of the surface exceeds the saturation temperature. Okay, so boiling is nothing but convective mode of heat transfer. Okay, so what is the formula which is related to the convection, that is Newton's law of the cooling. And what is that formula, Q is equal to H into A into delta T. Okay, so in that manner we have to write down the equation. Write down heat is transferred heat is transferred from the solid surface, heat is transferred from the solid surface, from the solid surface to the liquid, heat is transferred from the solid surface to the liquid, solid surface to the liquid, according to the law, according to the law, okay, which law is there? That is Newton's law of the cooling. And what is the equation for that? Q is equal to H into A into temperature difference. Okay, surface temperature of that solid surface and saturation temperature is for that liquid. So write down the equation. Q is equal to H into surface area into bracket Ts minus Tsat, Ts minus Tsat. Okay, or how to write this equation? H into S into temperature difference, that is delta TE, that is excess temperature. Okay, delta T is nothing but excess temperature. So write down where delta TE, where delta TE is equal to Ts minus Tsat, delta T is equal to Ts minus Tsat is known as excess temperature, is known as, is known as excess temperature. Okay, excess temperature समजले का बघा सगळ्यांना? वेपरायझेशन, वेपरायझेशन म्हणजे काय असणार आहे? इट इज द प्रोसेस बाय विच लिक्विड चेंजेस टू गॅस और वेपर. लिक्विडचं कन्वर्जन जे काही वेपर आणि गॅस मध्ये होणार आहे ते म्हणजे काय असणार आहे? वेपरायझेशन. देन व्हॉट इज मीन बाय इव्हॅपोरेशन? इव्हॅपोरेशन म्हणजे वेपरायझेशन ओनली ऍट द सरफेस ऑफ लिक्विड, म्हणजे जे सरफेसलाच फक्त लिक्विडचं कन्वर्जन वेपर मध्ये होणार आहे, म्हणजे हे लो टेम्परेचरला पॉसिबल आहे. दॅट इज नथिंग बट इव्हॅपोरेशन. देन व्हॉट इज मीन बाय बॉइलिंग? बॉइलिंग इज नथिंग बट वेपरायझेशन दॅट ऑकर्स थ्रू आउट द लिक्विड, म्हणजे पूर्ण जे काही लिक्विड आहे त्याच्यामध्ये थ्रू आउट काय होणार आहे? वेपर, लिक्विडचं कन्वर्जन वेपर्स मध्ये होणार आहे. म्हणजे हे कधी पॉसिबल आहे? ऍट दी हाय टेम्परेचर. दॅट इज नथिंग बट बॉइलिंग. ओके, अँड बॉइलिंग इज नथिंग बट कन्वेक्टिव्ह हीट ट्रान्सफर मोड इज देअर. Okay, so that involves phase change from liquid to vapor state, liquid to vapor state. Okay, then what is the equation which is related to the boiling? That is Newton's law of the cooling. And what is that equation? Q is equal to H into A into delta T. Okay, so this is about the boiling. Then what are the applications of the boiling? There are so many applications where we have to use this boiling. That is steam production in steam power plant. That is steam production is nothing but this is the application of the boiling. Then drying of the food. Okay, whatever the food is there, how to dry this food by using the boiling phenomenon. Then cooling the machines. Okay, so cooling of the machines is nothing but boiling. Okay, then heat absorption in refrigeration and air conditioning system, heat absorption is takes place due to the boiling. So these are the applications of the boiling. So write down the next point, applications of boiling. Write down applications of boiling, applications of boiling, applications of boiling. Write down first steam production in steam power plant, steam production in steam power plant, steam production in steam power plant. Okay, this is the first application of the boiling. Then second drying of foods, second drying of foods, drying of foods. This is the second application of the boiling. Then third, cooling the machines, cooling the machines, cooling the machines, cooling the machines, cooling the machines. And fourth one, heat absorption in,
heat absorption in refrigeration and air conditioning systems, heat absorption in heat absorption in refrigeration and air conditioning system. Okay, so these are the applications of the boiling, that is steam production in steam power plant, then drying of foods, then cooling the machines, and heat absorption in refrigeration and air conditioning systems. Okay, so these are the applications of the boiling. Okay, then next line, now write down. So what way the boiling heat transfer phenomena may occur? What are the different forms are there? So that forms we have to discuss. Okay, so write down the boiling heat transfer phenomenon. The boiling heat transfer phenomenon. The boiling heat transfer phenomenon may occur. The boiling heat transfer phenomenon may occur in the following forms. The boiling heat transfer phenomenon may occur in the following forms. In the following forms. Okay, so basically four forms are there. That is, pool boiling is there, then forced convection boiling is there, then subcooled or local boiling is there, and then saturated boiling is there. So these are the different forms in the boiling heat transfer is there. Okay, the boiling heat transfer phenomena may occur in the following forms. फॉलोइंग फॉर्म्स. ओके, जे काही बॉइलिंग ही ट्रान्सफर फिनॉमिना आहे त्याच्यामध्ये कुठले कुठले फॉर्म्स असणार आहेत? ओके, इन दॅट फर्स्ट वन इज पूल बॉइलिंग, देन सेकंड वन फोर्स्ड कन्वेक्शन बॉइलिंग इज देयर, देन थर्ड वन सब cooled or local boiling is there, and last one saturated boiling is there. Okay, so all of you write down first form, that is pool boiling. ओके, सो व्हॉट इज मीन बाय पूल बॉइलिंग? ज्यावेळेला आपण वॉटर आहे, समजा वॉटरला जर गरम करायला लागलो, तर जे काही सरफेसला जे वॉटर असणार आहे ते वॉटर काय असणार आहे? स्टॅग्नंट कंडिशन मध्ये असणार आहे. आणि तिथं जी काही हीट ट्रान्सफर होणार आहे बिकॉज ऑफ दी फ्री कन्व्हेक्शन, म्हणजे काय असणार आहे? बिकॉज ऑफ दी डेन्सिटी डिफरन्स. जो काय सरफेस असणार आहे, सरफेसचे मॉलिक्यूल गरम होणार आहेत, त्याची डेन्सिटी कमी होणार आहे, ते अपवर्ड डायरेक्शनला मूव्ह होणार आहेत. सो दिस इज नथिंग बट फ्री कन्व्हेक्शन, अँड विच इज स्टार्ट ऍट दी सरफेस ऑफ दॅट सॉलिड सरफेस. जो काय सॉलिड सरफेस आहे तिथे जे काही लिक्विड कॉन्टॅक्ट मध्ये येणार आहे सरफेसच्या, तर तिथं काय असणार आहे? फर्स्ट फिनॉमिना, दॅट इज free convection. Okay, so all of you write down the pool boiling. Pool boiling. Pool boiling. So write down, in this case, pool boiling, in this case, in this case, the liquid above the hot surface, in this case, in this case, the liquid above the hot surface, the liquid above the hot surface is essentially stagnant. Liquid above the hot surface is essentially stagnant, essentially stagnant, and its motion near the surface, and its motion near the surface is due to free convection. जी काही सरफेसची मोशन असणार आहे ती कशामुळे असणार आहे? ड्यू टू दी फ्री कन्व्हेक्शन. म्हणजे तिथले मॉलिक्युल्स हीट गेन करणार, त्याची डेन्सिटी कमी होणार. डेन्सिटी डिफरन्समुळे जे काय होतं दॅट इज नथिंग बट फ्री कन्व्हेक्शन. ओके, सो नियर द सरफेस इज ड्यू टू फ्री कन्व्हेक्शन. ओके, दिस इज द वन फॉर्म. देन राइट डाउन द सेकंड फॉर्म, forced convection boiling. Write down forced convection boiling. Okay, सो ॲज वी नो दॅट फोर्स्ड कन्व्हेक्शन आपण कशाला म्हणतोय, जी काही लिक्विडला मोशन असणार आहे ती कशामुळे असणार आहे, बिकॉज ऑफ दी एक्सटर्नल डिव्हाइसेस. फ्री कन्व्हेक्शन मध्ये जी काही लिक्विडला मोशन आहे ती कशामुळे, डेन्सिटी डिफरन्समुळे आहे. बट इन दी फोर्स्ड कन्व्हेक्शन द मोशन ऑफ द लिक्विड ड्यू टू दी एक्सटर्नल डिव्हाइसेस, म्हणजे आपण पंप यूज करू शकतोय, फॅन यूज करू शकतोय, ब्लोअर यूज करू शकतोय, अँड बिकॉज ऑफ these devices the motion of that liquid is takes place. Okay, so motion of molecules due to the external devices, that is nothing but forced convection boiling. Okay, so write down this refers to this refers to this refers to a situation where this refers to a situation where the fluid motion is induced by the fluid motion induced by external means full stop. The liquid is pumped and forced to flow. The liquid is pumped and forced to flow. Okay, so this is about the forced convection boiling. Then write down third, subcooled or local boiling. Subcooled or local boiling. याच्यामध्ये काय असणार आहे, दिस इज द थर्ड फॉर्म ऑफ द बॉइलिंग, सबकूल्ड और लोकल बॉइलिंग. सो इन दिस केस लिक्विड टेम्परेचर इज बिलो दी सॅच्युरेशन टेम्परेचर. जे काही सॅच्युरेशन टेम्परेचर आहे त्याच्यापेक्षा लिक्विडचं टेम्परेचर कमी असणार आहे, म्हणजे तिथं काय होणार आहे, बबल फॉर्मेशन स्टार्ट होणार आहे. Okay, and bubbles are formed in the vicinity of the heat transfer, and these bubbles after traveling a short path gets condensed in the liquid which has a temperature less than the boiling point. म्हणजे इथं टेम्परेचर कमी असणार आहे, म्हणजे जी काही विसिनिटी आहे तिथं काय होणार आहे, बबल फॉर्मेशन स्टार्ट होणार आहे आणि हे बबल्स लिक्विड मध्ये येऊन कोलॅप्स होणार आहेत. सो दॅट दिस फॉर्म इज नथिंग बट सबकूल्ड और लोकल बॉइलिंग. ओके, ज्यावेळेला बॉइलिंग स्टार्ट होणार आहे, लिक्विड आपण गरम करणार आहे, त्यावेळेला एक अशी स्टेज येणार आहे, असा एक फॉर्म येणार आहे, त्यावेळेला काय होणार आहे, तर बबल फॉर्मेशन स्टार्ट होणार आहे. तर हे बबल फॉर्मेशन कधी होत असते, ज्यावेळेला लिक्विड टेम्परेचर इज बिलो दी सॅच्युरेशन टेम्परेचर असणार आहे, त्यावेळेला नुसतं बबल फॉर्मेशन स्टार्ट होणार, ते बबल्स कोलॅप्स होणार आहे. दॅट इज नथिंग बट सबकूल्ड और लोकल बॉइलिंग. ओके, so all of you write down the information related to the subcooled or local boiling. That is, in this case, in this case, the liquid temperature is below the saturation temperature. In this case, the liquid temperature is below the saturation temperature, and and bubbles are formed in the vicinity of heat transfer, in the vicinity of heat transfer, in the vicinity of heat transfer, in the vicinity of heat transfer. Okay, so write down in the vicinity of heat transfer, and these bubbles after traveling a short path gets condensed in the liquid, and which has temperature less than the boiling point.
Okay, and what is the last form, that is saturation boiling. Here the liquid temperature exceeds the saturation temperature. Liquid's temperature is saturation temperature पेक्षा जास्त असणार आहे, and vapor bubbles formed at the solid surface are then propelled through the liquid by boundary effects and eventually escape from a free surface. म्हणजे आतमध्ये बबल फॉर्मेशन मॅक्झिमम होणार आहे आणि हे बबल सरफेसला येणार आहेत. ओके, आणि हे सराउंडिंग मध्ये एस्केप होऊन तिथं कोलॅप्स होणार आहेत. ओके, हिअर द लिक्विड टेम्परेचर एक्सिड्स दी सॅच्युरेशन टेम्परेचर पेक्षा लिक्विडचं टेम्परेचर जास्त होणार आहे सॅच्युरेशन बॉइलिंग मध्ये. वेपर बबल्स आर फॉर्मड ऍट दी सॉलिड सरफेस. जो काही सॉलिड सरफेस आहे त्याच्यावरती वेपरचे बबल फॉर्म होणार आर देन प्रोपेल्ड थ्रू द लिक्विड बाय buoyancy effect and eventually escape from a free surface. Okay, so all of you write down this information, complete this point number 3 and 4. Okay, after completion put that message, put that roll numbers in our chat box. Okay, remaining part we have to take in the tomorrow's lecture. All of you put your roll numbers in the chat box. Okay, sir. Stop the recording and leave the meeting.